Hello students, I hope you all are fine out there. So you are watching tomaxangtutorial and myself Kishan Kulung. So we have completed till question number 15 in our previous video, and today we will start from question number 16 onward. Okay, let's begin. So this is question number 16 from exercise 21a. In the left hand side we have cos a plus sin a whole square plus cos a minus sin a whole square, and we are asked to prove this equals to 2, isn't it? So let's do this. It is very simple. Okay, so this is cos a plus sin a whole square. We can assume this as a plus b whole square. A plus b whole square means a square plus 2ab plus b square, isn't it? Everybody knows this formula. So left hand side, let us copy as it is first. Left hand side equals to cos a plus sin a whole square plus cos a minus sin a whole square. This is left hand side. Okay, now we will apply the formula a plus b whole square, means a square plus 2ab, isn't it, plus b square. Are you getting me? Cos a is a and sin a is b. Okay, a square plus 2ab plus b square. Now here plus a minus b whole square means a square minus, oh I forgot to write a square minus 2ab, isn't it, plus b square. A minus b whole square means a square minus 2ab plus b square. So you can see plus 2 cos a sin a and here minus 2 cos a sin a. Same number, opposite sign, so you can cancel this, isn't it? This becomes 0. Now we have here cos square a plus sin square a, isn't it? Since we know that sin square theta plus cos square theta equals to 1, isn't it? Sin square theta plus cos square theta means 1. So this is cos square a plus sin square a. That means sin square a plus cos square a, isn't it? The same thing, 1 plus 1 equals to 2, sorry, 2 plus 3 equals to 5 and 3 plus 2 equals to 5. So the cos square a plus sin square a and sin square a plus cos square a, same thing. So cos square a plus sin square a means cos square theta plus sin square theta, that gives us 1 plus this cos square a plus sin square a gives us another 1. So 1 plus 1 is 2, and we have 2 in the right hand side, so this is proved, equals to RHS. I hope you got this. Now let's move on to the next question. Okay, now let us do next question. That is question number 17. We have cosec a minus sin a into sec a minus cos a into tan a plus cot a in the left hand side, and we are asked to prove this equals to 1 in the right hand side, isn't it? So let's begin. First let us copy the question as it is from the left hand side. LHS equals to cosec a minus sin a, isn't it, whole sec a minus cos a whole tan a plus cot a. This is what we have in the right hand side, sorry, left hand side. Now we will prove this equals to 1. Okay, so this cosec a can be written as 1 upon sin a, since cosec theta equals to 1 upon sin theta, isn't it? Sin theta and cosec theta are reciprocal of each other. Similarly, sec theta and cos theta are also the reciprocal of each other. Sec theta equals to 1 upon cos theta. Okay, and cot theta equals to cos theta upon sin theta. Okay, sin theta. Tan theta equals to sin theta upon cos theta. Okay, let me write that also. Tan theta equals to sin theta upon cos theta. This is theta. Okay. Okay, now cosec a means 1 upon sin a, isn't it? So minus this is sin a. Now this is sec A. Sec A means 1 upon cos A. Sec theta means 1 upon cos theta. So sec A means 1 upon cos A. 1 upon cos A minus this is cos A. Here we have tan A plus cot A. For the time being we will copy as it is. Tan A plus cot A. We will change this later on. Right now we assume there is 1 in the denominator of sin A. The LCM of sin A and 1 is sin A, isn't it? Sin A. LCM of sin A and 1 is sin A. So 1 into 1 is 1 minus sin A into sin A is sin square A. Sin square A. Whole. Here we assume 1 below cos A. So the LCM of cos A and 1 is cos A, isn't it? So 1 into 1 is 1 minus cos A into cos A is cos square A. Are you getting me? Yes, why not? So this is tan A. Now let us convert this into sin theta and cos theta. Tan theta means sin theta upon cos theta. So instead of tan A, I write sin A upon cos A. Okay, sin A upon cos A. Plus this is cot A. So cot theta means cos theta upon sin theta. Cos A upon sin A. Okay. Now 1 minus sin square A is cos square A, isn't it? Since we know the formula, sin square theta plus cos square theta equals to 1. That means cos square theta equals to 1 is already in the right hand side. Let us take this plus sin square theta to the right hand side. It becomes minus sin square theta, isn't it? So cos square theta can be written as 1 minus sin square theta, and similarly sin square theta can be written as 1 minus cos square theta. So 1 minus sin square A is cos square A. From there 1 minus sin square A is cos square A. This is cos square A upon this is sin A, isn't it? So let us put into instead of this bracket. 1 minus cos square A is sin square A upon this is cos A. Okay, into, now let us put bracket here. The LCM of cos A and sin A is cos A sin A, cos A sin A, isn't it? So sin A into sin A is sin square A plus cos A into cos A is cos square A. Now let me put this bracket a little bigger. Now here we have 1 cos A, here 2 cos square A, cos A, isn't it? So this cos A and 1 cos A gets cancelled. Here sin square A, sin A. So 1 sin A and 1 sin A gets cancelled. So we have cos A into sin A, isn't it? Cos A into sin A, where cos A into sin A. So this cos A and cos A cancelled, sin A and sin A gets cancelled. So we have sin square A plus cos square A, and we know that sin square theta plus cos square theta means 1. So sin square A plus cos square A is 1 equals to RHS. Hence proved. Isn't this easy? I hope you got this. Let us do question number 18. We have 1 upon sec A plus tan A in the left hand side, and we are asked to prove this equals to sec A minus tan A in the right hand side, isn't it? So left hand side equals to 1 upon sec A plus tan A, isn't it? So this is left hand side, and we are going to use this and prove this. Okay, since we know that sec square theta minus tan square theta equals to 1, sec square theta minus tan square theta means 1. So instead of this 1, I can write sec square A minus tan square A, because sec square A minus tan square A means 1. So in the denominator I have sec A plus tan A, sec A plus tan A, isn't it? So let us assume this sec A as A and tan A as B. Okay, so A square minus B square is A plus B whole A minus B, isn't it? So A plus B into A minus B. A minus B. Are you getting me? A square minus B square means A plus B into A minus B. In the denominator we have sec A plus tan A. sec A plus tan A. Now we have sec A plus tan A in the denominator, and in the numerator sec A plus tan A. So y should not be cancelled these two, isn't it? So now remains sec A minus tan A. Sec A minus tan A. So this is right hand side, isn't it? Equals to RHS. Hence proved. I hope you got this. Let's do another question, that is question number 19. We have cosec A plus cot A in the left hand side, and we are asked to prove this equals to 1 upon cosec A minus cot A. This question is similar to the question number 18, isn't it? So question number 18 and question number 19 are similar. Okay, left hand side we have cosec A plus cot A. Since we know the formula, cosec square theta minus cot square theta equals to 1. Cosec square theta minus cot square theta equals to 1. So we don't have any number in the denominator, means there is always 1 in the denominator. Are you getting me? There is never 0 in the denominator. If I write x, that means we have 1 in the denominator. If I write 0, that means there is 1 in the denominator. There is never 0 in the denominator. Okay, suppose if I write 2 upon 3, and at this time don't say that there should be 1 in the denominator and erase this 3. Don't say it, okay? Because if the number is mentioned already like 3, 4, so on, then we should keep that number. We should not replace that number by 1. Okay, if there is no number in the denominator, then we should understand there is 1. If there is 0, then we should understand there is 1, not 0. 0 upon 0 is infinity. Okay, 0 upon 0 is undefined. So if we write 0 also, there is always 1 in the denominator. Please keep this in mind. When there is no number in the denominator, then we should understand there is 1 in the denominator. So here we have cosec A plus cot A. That means there is 1 in the denominator. Now what we do is, this 1 means cosec square theta minus cot square theta means 1. So we copy the numerator as it is, cosec A plus cot A. Okay, 1 means cosec square A minus cot square A, isn't it? Because cosec square theta minus cot square theta gives 1. So instead of 1, I can write cosec square A minus cot square A. So in the numerator we have cosec A plus cot A, and in the denominator let's assume this cosec A as A and cot A as B. Okay, A square minus B square is A plus B, A plus B into A minus B, isn't it? A square minus B square is A plus B, A minus B. Now we have cosec A plus cot A in the numerator and cosec A plus cot A in the denominator. So why should we keep this? Let's cancel it. In the numerator we have 1, and in the denominator we have cosec A minus cot A. Okay, so this is the right hand side, isn't it? Equals to RHS. Hence proved. Okay, now let's move on to the next question, 20. Okay, now let us do question number 20. We have sec A minus tan A upon sec A plus tan A in the left hand side, and we are asked to prove this equals to 1 minus 2 sec A tan A plus 2 tan A square A. So let's do this. In the left hand side we have sec A minus tan A upon sec A plus tan A. Okay, now let us multiply numerator and denominator by sec A minus tan A, okay, into sec A minus tan A upon sec A minus tan A. When we multiply both the numerator and denominator by sec A minus tan A, the value of this expression does not change, because sec A minus tan A and sec A minus tan A can be cancelled and 1 remains, isn't it? So you can write this into 1, because this into 1 is this itself, isn't it? So multiplying by sec A minus tan A in the numerator and in the denominator as well, okay, at the same time. So this gives us sec A minus tan A into sec A minus tan A is sec A minus tan A whole square, isn't it? A into A is A square. Similarly, sec A minus tan A into sec A minus tan A is sec A minus tan A whole square. So in the denominator we have A plus B. This is A and this is B, okay? A plus B into A minus B. This means A square minus B square, sec square A minus tan square A. Now we know the formula, sec square theta minus tan square theta equals to 1, isn't it? So in the numerator we have A minus B whole square. A minus B whole square means A square minus 2AB plus B square. Are you getting me? A minus B whole square means A square minus 2AB plus B square. In the denominator we have sec square A minus tan square A. Sec square theta minus tan square theta means 1. So this can be written as 1. So we need not write this. Now we need 2 tan square A, isn't it? So we have only 1 tan square A here. So let's convert this sec square A into tan square A. So sec square theta is sec square theta equals to 1 is already in the right hand side. Let us take this minus tan square theta to the right hand side. It becomes plus tan square theta. Are you getting me? Minus tan square theta goes to the right hand side and becomes plus tan square theta. So instead of this sec square A, I can write 1 plus tan square A. 1 plus tan square A minus 2 sec A tan A plus tan square A, isn't it? Now this one we copy as it is, plus minus 2 sec A tan A we copy as it is. Oh, not plus, this is minus. Minus 2 sec A tan A we copy as it is. Now we have plus tan square A and plus tan square A. That means plus 2 tan square A. Okay, plus tan square A plus tan square A, 2 tan square A. So 1 minus 2 sec A tan A plus 2 tan square A is the right hand side, isn't it? So this is proved, equals to RHS. Hence proved. I hope you got this. Thank you so much for watching this video. So stay tuned, stay happy, stay blessed, and continue watching my channel because I'll be uploading more videos like this, okay?